All right. Yes, it does. KFC has coleslaw. It's green. It's gross. Coleslaw. Huh? Coleslaw is made of cabbage. I don't like it. When I go to White Spot and they put that coleslaw on the side of my plate, I never eat it. I haven't eaten it in 43 years. I don't like it. I don't like coleslaw. That being said, I do enjoy cabbage in other iterations, but I do not like coleslaw. But I do like curtido, which might mean something to somebody in this room. Yes, Joy? Do I like borscht? I could take it or leave it. Is anybody in this room of South American descent? So, do you know what curtido is? No. Spicy pickled coleslaw. It's delicious.
Yeah.
My son has a thing about eyes. If he was in this room right now and watched you put those drops in your eyes, he would already have run away. No, I'm not joking. Like, you can't even talk about eyes around my son. He gets all... I'm dead serious. It's actually kind of funny. He doesn't like... He can't handle eyes. He's got a thing about eyes. 13. He's got a thing about eyes. He's got a thing about wasps. Everything else, he's cool. He's fearless about everything else. But wasps and eyes, can't handle them. He can't do it. He runs screaming like a crazy man. He once jumped off a cliff to avoid... I'm not joking. We were at a cliff jumping spot. He was on a cliff. And he was like, I don't know if I'm going to jump down. Then a wasp flew by him. Then he jumped. Unfortunately, right above him, somebody else jumped at the same time. And there was almost a mid-air collision. So, all right, back to work. Please notice, the cosine law, the cos law, allows you to find missing sides or angles when you don't have a right triangle, just like sine law, except, as I showed you earlier, sometimes you cannot do sine law. So we use the cosine law. And it's all explained on this page, but let's put it into perspective. There are two iterations of the cosine law. One is this. 10, 12, 87. This is one time we would use cosine law, when we have an angle. What's the proper math word for this?
Array?
No. Oh, I can't remember what it is. When you have an angle surrounded by sides. There's a proper math word for that. I just can't remember what it is right now. So in this case, I have an angle right there, and it is surrounded by sides. This is a cos law situation. Everybody cool? The other time we use cos law is here, when you have all three angles. Those are the two ways we do cos law. Everybody cool? Now, it's pretty simple, okay? In this case, what are we looking for on the left? We're looking for a single side, yes? Everyone agree? Okay. So, since I'm looking for a single side, I can use this cos law exactly how it is. Why? Harmon. Because it says c squared, and c squared is a side, because it's little c, right? Now, here is the trick. Whatever side you are looking for, you make it little c. Which makes this angle what? Big C. Makes this angle either A or B, AB, AB, or AB. Is everybody cool? Yes.
So can be B squared equals A.
Yeah. You can change them around. But you guys have trouble doing algebra. Yeah, you do. You're about to prove it to me.
I reviewed cosine law yesterday, so.
Oh, okay. Actually, I kind of screwed this up. Sorry. Sorry.
Isn't there 2 angles on a side?
No. The other iteration of cosine law is when you have all 3 sides. Sorry about that. All the sides. Now, in the other iteration of Coleslaw, I need an angle, yes? Now, observe. In the cosine law, is there an angle anywhere?
Yeah.
Where? Cos C, right there, right? So what I need to do if I'm on this side, I need to rearrange to get C by itself. Now, look closely at this. What does this version of Coleslaw find? It says right there. It's written C squared equals. What does this version of Coleslaw find? No, it finds C squared.
Oh.
Do I want ever to find C squared? So what do I need to remember to do? I got to remember at the end to square root, just like Pythagoras. What does a rearranged version find? No. It will find cos C. So what do I need to remember to do at the end? Inverse cos. Everybody good? Your job right now to prove if you are good at algebra like Lena says you are, is to take Coleslaw and rearrange it so it cos C is by itself while I pee. Everybody good? Go. I've lost my keys. I found my keys. I'll be back in a minute. Hallie, you're in charge.
Okay. 87 squared equals a squared plus b squared. So square root. Coleslaw is just Pythagoras.
No, it's not. It's still, then it will start to be squared and b squared.
Just checking everybody's work over for Marley.
No,
Okay, you guys got this done? What is it? A squared plus b squared plus c squared minus 2ab. Is that right? Nope. And that's okay. I haven't shown you how to do it. What do you got?
B squared equals, I mean like a squared plus c squared minus 2ac cos b or something like that.
But I want cos c by itself.
Like no, but together for the equation.
I'm trying to find an angle. Okay, Damaris.
What if we a squared plus b squared minus cos c equals a squared plus b squared minus 2ab times c squared?
You're getting a little bit warmer. What? 70?
What?
I see what you've done. I just wanted the equation. Yeah, yeah, yeah. Steven. Would it be like when we, no. So what happened here was Green gave us the angle of C, which I assume you made this was C? Yeah. She told us that this was 78, did you say? 70? 70. But I just wanted her to do the equation. Now, what the equation is this. I got to get that cos C by itself, yeah? Okay, so everything's got to move away from cos C, doesn't it? So this has to go over here, and this has to go over here. What happens to them?
And you have to divide by 280.
What happens to them? They become negative. So I got C squared minus A squared minus B squared. Then what do I do here? What math is happening here? Multiply. How do you get rid of multiply? Divide by negative 2AB. Now, Green got rid of this negative by making one of these positive. I don't exactly know how you did yours, but this will work. Does everybody understand? It's just algebra, but it's the same law. Everybody cool? All right. Let's try and work a couple of these through. In triangle ABC, so I got to draw a triangle, yeah? I'm going to read the whole thing. AC is 20, BC is 11, and ACB is 20 degrees. So, AC is 20. AC. BC is 11. And angle ACB is 20. There's my triangles. Everybody cool? Yeah. Calculate angle AB, or calculate AB, this distance, and angle ABC. So I also need X and I need Y. Is everybody cool? All right. So looking at this right now, is this a sine or a Coleslaw situation? Cosine law, right? Because I have an angle surrounded by sides, yes? So I'm going to go ahead and do that. Now, I made this angle C with this question on purpose. If that's big C, then what's this? That's little c. So I can use the Coleslaw as it's written, correct? So C squared equals A squared, 20 squared, plus 11 squared, minus 2 times 20 times 11 times cos 20. It'll show up. It always does. Now, this is a little bit tricky to punch into your calculator, but you can all do it in one shot. The first time you do this, you're probably going to want to leave the c squared. You're probably going to want to punch that in first, get an answer, and then square root it. But if you're really good with your calculator, you can do it all in one shot. You just put a square root before you do this. Does everybody understand? Now, if you're not so hot with your calculator, it's not a bad idea to do a few of these piece by piece. 20 squared is 400 plus 121. 2 times 20 is 40. 40 times 11 is 440 cos 20. Right? Everybody cool? So that's 521 minus 440 cos 20. Do that with your calculator and you're going to get c squared. Then what do you need to do? Square root that. So everybody try and do it. You can try it at any level here and try and get the right answer. And what do we get for an answer for C?
8.7. That's what I got.
So I've got an 8.7. What else do I have? I have what? 10.37. So 10.4. Do I have anything else? Pardon? 10.32? So close enough to 10.4. Anybody got something else?
107.5. Punched stuff in and it gave me that.
What do you got? Another 10.4. What else? 10.4. 10.3 something. 10.4. All right. So, Luke, I hate to tell you, but it is indeed 10.4.
Yeah.
Is everybody cool? All right. So once I know that is 10.4, now what do I have? What do I have right there? I have a pair, so what can I use? Sine law to find y, right? 10.4 over sine 20 equals what? (20 over sine y). What am I going to need to do at the end to find y? Shift sign. Go ahead and work that out. What do you know about y?
That is the opposite side.
When you do your work, y has to be what?
Opposite.
No. The answer has to be what?
Oh. The middle.
Bigger or smaller than 20?
Oh.
Yeah, you do know. The value for y has to be bigger or smaller than 20 degrees. Why?
Why? Because 20 degrees is the smallest one out of that, so the opposite side of 20 is the smaller side, so we know that y has to be the biggest one.
Right. So what's y? 20 sine 20 divided by 10.4. And then I shift sign that. And what do I get? 41. Any corroboration of that while I punch it into my calculator? Anyone, any corroboration? Is it 41 indeed?
Yeah.
Yes. Does that make good sense? Let's check. If that's 41 and that's 20,
That doesn't make sense.
if that's 41 and that's 20, what is that?
That's not a right
That's 61, right? So the other angle must be what?
It should be smaller though, shouldn't it?
Just wait. That would make this 119. Is that possible?
No.
No. It isn't. Is it? So, let's think for a second here. This number is going to give me a sine value, isn't it? What is it? What do you get on your calculator when you punch in that?
6.8.
Yeah.
You get 0.657, correct?
What the hell?
Everyone agree? Is that sign positive or negative? Is everybody okay with that?
I keep getting 6.8.
Well, then you're punching it into your calculator wrong. Put brackets on the top, dude. Like you always need to do. Is everybody okay with that?
I still did brackets and it still gave me 6.8.
Push open bracket.
Yeah.
Push 20. Do you have a forward or a backwards calculator?
Forward.
Now push sine. Now push 20. Now push close bracket. Now probably push close bracket again. Now push divided by. Now push 1. Now push 0. Now push decimal. Now push 4. Now push equals.
There we go.
0.657, yes? Now, you guys are intelligent young people. What have you just learned about sine?
Use the opposite and hypotenuse, and it's on the second quadrant.
It could be over here, couldn't it?
Yeah, and it could be in the first one.
So we know that it's 41 in the first quadrant. So what is this? What's this?
Oh, that's 41. So
41. So what's this?
Overall angle, which is 41 plus 90.
139, correct? Does that work?
Isn't it 131? Because 90 plus 41.
No, it's 180 minus 41.
Oh, minus.
Does that work? That makes this 139, right? Everyone agree? What's 139 plus 20? 159. What's 180 minus 159? 21. Now, is the smallest side across from the smallest side? Is the middle one across from the middle side? Is the biggest one across from the biggest side? So what happened? Is this triangle actually the triangle that we are drawing? No. Why did we draw the triangle?
For reference.
For reference. Then you must use your brain. Right? Because that couldn't have been 41. What does this triangle really look like? 139, 20, 21. Everybody understand?
And it's on the 360-degree plane.
Everybody understand? That's why we do the unit circle stuff before we do sine and cosine law. Because if you don't do that unit circle stuff, everybody puts 41 there. Because their calculator said so. Is the sine of 41.657? Yes. But so is the sine of 139. Does everybody understand? Excellent. You guys is on fire. Turn the page over. Mr. Myers. PQR.
That's awesome.
Sine law is ABC. Except it doesn't matter, does it? Because sine and cosine law could be $, peace sign, and lightning bolt, couldn't they?
Let's make it that.
So, let's see what we know. RP is 7. RP is 7. PQ is 10. Calculate the measure of angle Q. Oh, do we have a third one? Oh, yes. RQ is 8. Calculate the measure of angle Q. Now look at the triangle. Whether or not that triangle is right, you know some stuff about it. What do you know about angle Q?
That it's C.
That it has to be the smallest angle, yes? So since I'm looking for angle Q, what should I make it?
The theta.
Yeah, we should make it C, right? Because we know cos C equals C squared minus A squared minus B squared over negative 2AB. Right?
Julio.
What is C squared?
The big C of those is
7 squared minus, what is A squared? Does it matter? No. 10 squared minus 8 squared over negative 2, 10, and 8. Which is 49 minus 100 minus 64, which is going to give me a negative number, isn't it? That seems weird. But then you're dividing by a negative number, so you end up with a positive anyway, right? So, if you're going to punch all that into your calculator, you can do it all at once, but what do you got to remember? Bracket, bracket, and bracket, bracket. Because if you don't do bracket, bracket, it's going to divide this by 2 and then multiply that whole answer by 80. You got to bracket, 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 bracket. And then what do you got to do at the end? Because that's giving me cos C. What do I need at the end?
Inverse cos.
Shift cos of that. So try to punch it in all in one go, or
I'm piecing it.
or piece by piece. It doesn't matter.
Whoa, weird numbers. 45. Inverse cos of cancer. Don't mean it.
And what do you get?
And you get 213.
About 44.
What do we get?
Domain error.
44 degrees.
What are we cosigning? The answer? Or what we
You
get?
cosine this, you shift cosine that answer, that decimal.
I got 1.33 after dividing 213 by 160.
Can't have a cos of greater than 1, so you screwed up somewhere. Again, what's difficult here? The math or making your calculator do the work? The calculator is the harder part here. So why would you go to it right away if you don't know what you're doing? Go piece by piece. 49 minus 100 minus 64 over negative 160. Right? Then you can go ahead and do that. 49 minus 100 is negative 51, minus 64 is negative 115.
Yep, I got
Yep.
it.
I know.
I got it, Mr. Myers.
You go, guy. Does 44 make sense?
Yes. Well, we don't. Yes, because it's going to be the smallest one out of that because side.
But again, we don't know if the drawing is correct. So what could we do to make sure it's right? We could do one more angle. We could use some sine law now, couldn't we? To check, right? So just to make sure, we could do some sine law. You guys do sine law while we're waiting, because I'm apparently never going to connect again. Hey,
How do we use sine law?
well, you have 7 and 44 now.
Okay, so 7 sine 44.
So, does that work? Do I have the biggest angle across from the biggest side? Do I have the littlest angle across from the littlest side? Do I have the middle angle across from the middle side? So did I do it right? Yes. This question is fun because I used to have it on a test, and then something really funny happened.
Wait, go back up. I just need to review for it. So sine R, because hold on, 10 is A side. That's right. That's it. I got it.
Okay.
10 over sine A then.
This question used to be on a test. And then one year, one kid reading this question said that the plane was 34,450 kilometers east of the tower. The plane was in outer space.
The Earth isn't that big.
What is it really? 50. The flight is flight 344. Numbers aren't written that way. I know that. It's not a mind trick. That's how you say what a flight is.
I would have said, what's your flight?
Flights are done.
24,450.
Okay.
And I would have got it right.
Okay. So, the tower is here. The flight 344, I'm going to call him W for WestJet, is 50 east.
I saw flying with shit.
At the same time, Jazz Flight 712 is 25 kilometers from the tower. Somewhere, if the angle between the two planes from the tower is 20, how far are the planes apart from each other? So there's 20.
So we're like looking at the tower from above and looking at the planes.
Yep. Here's Jazz.
And they're both east.
They have to be because this guy's there's only 20 degrees between them. 25. Now, some of you may say, Mr. Myers, why would we ever need to know cosine law? Have you been in a plane?
Yeah.
Excellent. Are you aware that there's more than one plane in the sky at any given moment? Yes. Are you aware that computers often stop working? Excellent. What do you think happens around, say, an airport like New York City if the computers go down?
Boom.
Somebody better be able to do some trig, right? Because that's what they do. Everybody understand? So let's figure it out.
So you don't have a backup laptop computer thing?
They do.
Why don't they use that one then?
The point is, somebody still needs to know how to do it. All right, what am I going to use? Sine or cosine law? Cosine law. Which version? Cos C or C squared?
C squared.
C squared. Why?
Because your sandwich is 2.
Because we need a side. So what am I going to make this?
C.
Lil c. And then I just go to town, right? C squared equals what? What's A squared?
C squared equals 25 squared plus 50 squared.
Minus 2 times 25 times 50 times cos 20. Now, if I need to go piece by piece, it's not that hard, right? Or you can try it all in one go.
I forgot already.
Who has a number for me? $19.8. That's one number I've heard. I got a 27.8.
Yeah.
I got a 27.9. You want to change yours? Yeah. Spring break's coming up.
Oh,
What do you got, Luke?
24.2.
I got a 24.2. Any other numbers?
I feel like Monsters Inc. Got a 2319. 2319.
Any other numbers? I have 27.9. Let's check. 625
Mine,
plus,
Coast 20.
what's 50 squared? 2,500 minus 2 times 25 is 50 times 50 is 2,500
625.
cos 20, right? Okay, so that's 3,125.
I got, yeah. And then you use
3,125 and 2,500 cos 20 is 2,349.23. 3125 minus cos 20 is 775.76.
wait.
Then I square root
How did you?
27.9.
Oh, you did Coast 20 before, or
2,500 minus cos 20. You have to do bed mass. This
okay.
is one thing. All right?
And you're multiplying by Coast 20, so that's why you do it.
Since that's all multiply, you have to do it first. You have to remember bed mass. Because your calculator always does bed mass. You have to know what your calculator is doing. Your calculator can only do what you tell it to do. So if you punch something in wrong, it's going to do bed mass. So if you do some weird brackets or something funky, you're not going to get the right answer.
27.8. Yep.
27.9 is 27.85. Everybody Gouda?
Yes.
You try to do number 4.
As complicated as this one is, it kind of seems more simple than signing off because it's more methodical. To me, anyway.
Don't go on past trying to draw the triangle first. Let's make sure we're all drawing it right. Starts at the harbor, yes? Does direction matter at all? No.
Slightly, I mean,
Ship A sails away. How far does ship A go?
13.
13. Ship B sails away. How far does ship B go? 24. How far apart are they? 10. So now I want that angle right there. There's my theta, right? So what should I make it?
10 squared minus
Big C.
24 squared minus 6.
Cos C equals 10 squared minus 13 squared minus 24 squared. Yeah? Over negative 2 times what?
AB.
Which is
24, 13.
24 and
You
13.
should make a Monsters Inc. question with 2319 in it.
Okay.
Because it's just like,
Just for you.
you got a 2319?
I hear you. Just for you. I will do so.
Do that in your next book.
Let's have an answer. Delicioso. Is Dora the Explorer in Germany as well? Does she speak in Spanish or German in Germany?
Then my dad blocked it.
Oh no! My answer's not right. Something's wrong.
All right. What's wrong with this?
You get a.
Yeah. It's an impossible triangle. In a regular class, what do you think happens with this triangle?
We go.
What do you think the class does?
We just explode.
They change things around to make it work. They assume they made a mistake. What did you do? You said this doesn't work. It's greater than 1. Because you know you did it right, correct? Absolutely. I wrote this question this way on purpose. It's an impossible triangle. This cannot happen. They would be further apart than 10. Does everybody understand why I did this to you? You know how to use this stuff, right? You know how triangles work. Trust your process. All right? Everybody understand what I'm saying? Okay. What if I made this 15? Could we do it then? What would change?
The C would be over there.
No.
15, right? Because
What would this be instead of 10?
15.
15 squared. Right? Would that work?
Let's find out.
Does that one work?
Yes.
What is it? 34. If I make that 15. Why did I do it to you? Why did I put it in your notes? Because I need you guys to know. I need you to understand. Right? Just like that very first question we did. If you just read what was on your calculator, did you have the right triangle?
Yeah. Oh no.
No, you said it was 41. It couldn't be. Does everybody understand? You have to still trust your process, and you have to do the process. All right? The math won't lie.
You lie.
And you are not allowed to change the math to make it work. Understand? All right. Let's try the very last one, then I'm going to shut up. What's the next thing in your book, by the way?
You don't know.
Now, after the crumbling tower, what is next? Some practice? Okay. We'll call that, so this page 80, Stranded Tourist. Okay. As you can see, there should have been some practice in the way there. I don't know why you don't have it. So what we're going to do is we're going to make this not an assignment because you haven't had any practice with it. So I don't want to give you an assignment, right? So how about this, though? Is it all right with you if I make quiz 3, which is on sine and cosine law, an assignment instead of a quiz?
Yeah.
Which means you can work on it with your notes and everything and each other. But it's going to actually count, whereas quizzes don't usually. Is that cool with everyone? Because I do want you, before you're tested on cosine and sine law, to actually try something without any answers. Yeah? Okay. So this will be practice. We'll go over it Monday. And then on Monday, I'm going to give you quiz 3, but it's going to be an assignment. Everybody cool? And then if you notice, I have a review 2, the next thing, right there. That is all trig past SOHCAHTOA, because you already did a SOHCAHTOA review. Cool? Everybody good? All right, so let's do the crumbling safety tower, because I love the drawing. This is a beautiful question because it requires you to do everything you know about triangles in one question. Technically, I could make this question your entire trig exam. No. Because if you screw it up, then you would fail. So, let's go. I got my tower. I need to find out how tall it is. So, a man stands at a point A and measures the angle to the top of the tower at 18. She then walks 20 meters closer up to the fence and finds it as 31. Right? Because she can't get there to measure the bottom, so she has to use more than one triangle. Everyone agree? Okay. So now I want to find the height of the tower. How do I find the height of the tower?
You have to use triangle, the 31 triangle. Oh, wait, no, you don't.
I need to use the 31 triangle because there is my opposite, my theta, and my height. Right? Can I get this measurement?
Yes, you can, because you can find the hypotenuse of the triangle of 31 degrees.
How?
You can use 18 and 20. So you have the theta.
So I got to use, hey, Mr. Como, how are you? I got to use that triangle, don't I?
Yeah, to find that side.
Okay, do so.
Okay.
You've got to use one to find the other. You have SOHCAHTOA, cosine law, sine law, unit circle trig available to you, right? What I am not seeing is anybody talking to the person beside them. This isn't a test. Put your heads together and figure it out. I will give you this hint. Luke is on the right track.
First time ever.
That is not true, Luke. Oh, yeah, sure. Did I need to go further back, Rhea? You're cool? You know why it works, right? Like why the 10 didn't work? And why I turned it to 15? Oh, this is not 10. That's 15 now. And then when you run all this through and shift cos at the end, you're going to get 34. You got to remember to shift cos, right? Because the cosine law finds the cosine of the angle. And we need the angle.
I like how it's not drawn accurately.
What do you, yeah, you know, I only put that there for you guys. Right? It's drawn pretty accurately. I'm pretty proud of that question. My favorite part is look at what's flying around. I even put some birds in. Or bats. Whatever you're, you know, whatever you're in the mood for.
Bats don't look
I
like
got that hypotenuse at 6.1. I don't know if that's right. The math seems
really
right.
dumb. That almost looks like their face. It's pretty dumb, by the way.
And that would be
Somewhere in our
20 sine 18.
right.
That's SOHCAHTOA trig. Where is there a 90-degree triangle with that?
Because this is not an
Was it because I said unit circle trig? So maybe reference angles?
No, obtuse. Where did this?
Yeah.
Fireman? Oh. Why was it so hard to find out how? I always just.
If you feel that you have the height of the tower, feel free to move on to page 80 and work on that.
Oh, I was on the right track, but I don't know what to do.
I mean, it should be. I don't look like right.
Of course it's a right angle. You're going straight up from the ground.
Well, maybe the tower's a bit shallow. Never know. Our house is 378 years old. Yeah, things kind of move around in the third floor.
A, that's B. Same piece. So A over sine A. And A sine
I don't even know what the two accurate, whatever Harvard said, triangle is.
A over sine and B, A side B. What side is that?
But it said not draw accurately, so it might not be impacted.
It has to be C and sine B.
But he just said it's going straight up.
And side C equals 20.
Wow.
C, which is 20.
What if it's
Sine.
Or that doesn't
straight.
really like
What? I'm considering possibilities here, okay?
the first thing that we have to find
Dead lines.
What?
Stop lawyer balling! Stop it! Stop it! Oh, we can't possibly put a slide there. What if somebody slips and hurts themselves? We can't have a swing set. What if somebody falls off? We can't possibly put a diving board in our pool. Somebody might get hurt. Stop it!
Well, it says not drawn accurate.
That's because this is not really drawn as 31 degrees. If I get out a protractor, that's not 31. Okay? That's not 18.
You know, I just said to know you.
You did well. Harmon,
I'm using sine law.
of course that's a right angle.
That makes everything easier.
Of course it's a right angle. Measure my height. The ground is flat and you measure straight up.
I can do this like this.
All right, apparently this needs to be made clear to everyone.
That doesn't really work.
This is a 90-degree angle.
Mr. Meyer, I'm using sine law to figure
Now
out
it's
side A.
very
I'm
dangerous.
Now it's really dangerous. That thing's really about to go.
That thing is already gone. The way it looks. She might not even have to measure the tower now.
Just wait for it to fall and then measure the rubble.
Yep.
Word.
I just want to like double check with you because I'm a little bit unsure of how like I'm getting to where I'm getting.
I'm about to go over it.
Oh, never mind.
Okay. Yes, you may.
I tried to use sine law, but I gave up.
Because not enough information
There is enough information.
to get spare and pair.
No, there is definitely enough information.
I can just do Sokotoa. Look,
You cannot do SOHCAHTOA.
If that's 90 and that's 31, then that means the top angle of that tower is 59.
yeah, it is.
Okay. But, so you have 3 angles. Still can't do SOHCAHTOA, you need a side.
Oh, damn.
Oh, damn!
How am I going to use sine law here? You only have one side.
You don't!
No? Well, rinse that, then.
How many people have moved on to the assignment? Sweet. So you have an answer for number 5 here? Sweet. 3 more minutes. And then we will be going over number 5. Sadly, I have eaten all my gummy bears, so I cannot offer it to the 3 of you for getting it right. But I can give you an IOU. Write it on the board. I don't care where. If you want gummy bears, write it on the board so I remember to give them to you. When I was a kid, McDonald's used to bring you their Happy Meals in a plastic thing like this that was shaped like a UFO that you could clip the lid on, and it had a spot for your thumb so you could throw them like Frisbees. Back in the day. No, because then there would be 20 billion more plastic things from McDonald's. They also used to have their burgers in styrofoam containers, so they stayed warm. They don't do that anymore either. They also used to have their burgers under a heat lamp, so when you walked in and ordered a burger, you got it right away, instead of waiting an hour and a half. When I was a kid, McDonald's was actually fast food. Well, it was fast. It still really wasn't food.
The fact that you asked if I got it, like I would get it. So the fact that she doesn't get it makes sense because then.
No, I got the answer.
One more minute. It's a race.
It won't go away no matter how much.
Gagny, Veronica, and Green are already getting gummy bears. I'm willing to give gummy bears to one other group. You feel you have an answer? Yep. All right. You don't know if you're right yet, but...
No, I tried.
I'm a hippie.
Yeah, sure.
Beating on a bongo drum.
So I can't use sine law.
Yes, you can use sine law.
I said not to.
I never said not to use sine law.
Yeah, but I'm trying to find sine A of the first triangle that's 18 degrees. I have one side of one angle. Sine.
All right. Eyes up. Okay. You got yourself the green triangle. You got yourself the blue triangle. You got to find one side of the blue triangle or you can't do this, can you? To find one side of the blue triangle, you probably got to use this one that's got both of them, yeah? But to do that, you need to be able to do SOHCAHTOA, sine law, or Coleslaw. So, can't do SOHCAHTOA, it's not 90 degrees. Can't do Coleslaw because you don't have an angle surrounded by sides. So, got to be sine law. How can I do sine law, Mr. Myers? Damaris, how can I do sine law?
Your bottom line is 180, so you just subtract.
That's 149.
Oh!
Why?
Oh my god!
Because a unit circle trig.
I'm in
So if that's 149 and that's 18, this is 13. which gives me a sine law pair.
It was that simple?
So, 13 over sine 20, I lie, other way around, idiot head. 20 over sine 13 has to equal the blue hypotenuse, so I'm going to use blue, over sine 18. 20 sine 18 divided by sine 13 will give me blue H. Now, in the blue triangle, theta is 31. H is 20 sine 18 divided by sine 13. And I need opposite, which is my little h. What uses O and H? Sine 31 equals opposite, little h, over this number, 20 sine 18 divided by sine 13. Numbers on the bottom, so it's this times this, yes? So H,
Mr. Myers, that's not something really weird.
one sec.
I accidentally did SOHCAHTOA and I didn't realize it wasn't a 90-degree triangle. But I divided the answer which I got for that hypotenuse, which we got here, by 3, and I got the same answer that I got by doing SOHCAHTOA off of the non-90-degree triangle.
So what does that tell you? That you are right, or you are in a very lucky situation where that happened to work out?
No. I'm just saying it's interesting because I didn't do this. I'm just looking at your answer there, and through that sine law you get 19 whatever. I divided that by 3, and I got the answer to finding the hypotenuse of sine if I divide it by 3. It's really weird. So maybe.
What is your answer, Damaris? What is your answer? 14.2. And the answer is 14.2. Go put your name on the gummy bear list.
Never mind. It's very close to it, though. It's weird. Someone else does it.
No, it's not that weird, Luke, because remember, that happens in math all the time, right? The Egyptians got very close to pi doing something totally different than circumference divided by diameter. Now, how many other people found this?
I forgot about that.
Excellent. Well, then there should be more names up there for gummy bears, shouldn't there?
No, because that's simple as hell.
You didn't get to the end, Harmon? Oh. You didn't get to the end, Olivia? You got it right? Go get yourself some gummy bears. You got to get paid, sister. Whoa, 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 whoa. Yeah. Do some trig over the weekend. Yeah. Let's say, how much is there? There's the stranded kayak. How many pages is there? What's after the stranded kayak? There's 3 pages? What kind of animal am I?
Let's do the first page.
All right. 85 and 86. Yeah, I wouldn't have noticed. 85 and 86 is homework.
Times 2.
And we'll do 87 when you get back on Monday.